Assalamualaikum and hello everyone. Chapter 4 Forces. So for today's video, we are going to focus on 4.1 Basic of Forces and Free Body Diagram. So I believe that you have learned some of the types of forces during your school. For example, we have weight, tension, normal force, friction, external force, which are pull or push. Then in this subtopic, you're going to have to sketch free body diagram correctly and then determine static and kinetic friction. Fs is the static friction, Fk is the kinetic friction. So later we're going to see what are the differences between these two. So forces are physical quantities that cause an object to move, stop, change its direction and change its shape. So force adalah satu kuantiti, satu kekuatan yang boleh menyebabkan suatu objek bergerak, berhenti, ubah arah dan ubah bentuk. Okay, and then force is a vector quantity. So bila kita kata vector quantity, the value you should give with the magnitude and direction. And then vector quantity represented by arrow. When we want to draw a free body diagram, we are going to use a lot of arrows. Okay, so the unit for force is kg/m², and Newton. Okay, so let's look at the first basic force, which is weight. Weight is the force of gravity on the object, where m is the mass and g is the gravitational acceleration. So for any object that has mass, setiap objek yang ada jisim will experience gravitational acceleration. So the product of m times g will give you the weight. To draw the vector for weight, the direction is always towards the center of the earth regardless of the position. Tak kisahlah bentuk dia, kedudukan dia macam mana pun, mesti daripada titik pusat dia, the vector is going down. Okay. So the next force is tension. Magnitude of the pulling force exerted by a string, cable or chain on another object. So ini tension ni akan berlaku apabila kita ada tali ataupun kabel ataupun rantai yang di-attach pada another object. Okay, and then the directions of the tension vector is away from the object along the rope. Okay, so for the first diagram, the string is this one over here. So the vector for the tension is going away, menjauhi object. So this is the object. So direction of tension force naik ke atas, menjauhi objek tersebut. So the second diagram, kita punya tali berada pada kedudukan yang ini, yang warna hitam ni. Okay. So arah tension kita menjauhi objek. This is object, so punya anak panah menghadap sana. So let's say we have two objects attached together by a string. Okay. So di sini kita kena lukis satu keratan. Okay, menunjukkan arah tension untuk setiap objek. So this is the object. String yang attach kat dia, arah anak panah T menjauhi. Okay. The second object. So the tension force is moving away from the object. So we have T, and they have the same value. So T ni magnitude dia akan sama dengan T di sini lah. Okay, for this diagram over here, this is the object. Jadi bila ada tali, the tension force akan menjauhi this object. Okay, so for this vector over here, later on kita kena resolvekan according to axis. Now given that the theta is near the y-axis, so y-axis yang akan pakai t cos theta, x-axis adalah t sin theta. Next we go to normal force. So normal force, the contact force component, which is perpendicular 90 degree to the surface contact and exerted on the object by preventing the object from penetrating the surface. So this normal force will only exist when two objects are in contact, bila ada dua objek bersentuhan. Okay, and the direction of the normal force is away from the object or the surface of support perpendicularly. Okay, so now for example for the first diagram, kita ada objek diletakkan pada lantai. So the normal force is going up from here sebab in contact with the floor. Okay, and then kalau objek tu berada pada rem, so the surface is like this. Therefore, 90 degree dengan surface tu, so normal force kita bergerak ke arah sini. Okay, and then if the object dia duduk dalam keadaan macam ni, kita kena cari kita punya surface kat mana. This is our surface, so 90 degree to the surface. So this is the normal force. Okay, when we have two objects in contact in this position, okay, object A, dia akan menyebabkan normal force pada objek B, dan objek B akan menyebabkan normal force pada objek A. So the keyword over here, normal force will exist when two objects are in contact, bersentuhan. And then external force could either be pull or push. Okay. Next we go to friction force. Force exerted on the object by a rough surface as it moves across it. Make an effort to move across it. Friction is in the opposite direction of motion. Okay, so dia kata dia adalah force yang dikenakan pada objek yang bergerak pada permukaan yang kasar. And then, kalau soalan kata, dalam soalan kita tu, the smooth surface, permukaan yang licin, jadi kita assume tak ada friction force. So, the direction for the friction force is opposite of motion. So, let's say, objek kita bergerak ke kanan. Okay, so arah friction force kita akan opposite dengan direction tersebut. So, this is the keyword, friction sentiasa opposite dengan arah motion. Bukan arah force, bukan arah applied force, tapi arah motion. Okay, contohnya kita ada satu objek berada dalam kedudukan condong. We apply a force over here. Kita apply force. Okay, tapi force kita ni tak cukup kuat. Okay, katalah tak cukup kuat. So, objek ni dia masih lagi bergerak ke bawah. Dia masih lagi bergerak turun daripada satah tersebut. So, arah friction adalah arah atas. Sebab dia opposite arah motion. Bukan opposite arah force. So, bila saya label sebagai V ni, maksudnya dia ada velocity lah. Dia ada pergerakan turun. So, F akan opposite the motion. Bukan opposite force yang kita apply. Because boleh jadi arah force ni tak cukup kuat untuk tarik dia ke atas pun. So, there are two types of friction. The first one, we have static friction. Geseran yang berlaku apabila objek berada dalam keadaan tidak bergerak. Okay, and then kinetic friction, geseran yang berlaku apabila objek bergerak. Kinetic, bergerak. Friction force prevents stationary object from moving. So, this is the formula for the static friction equals to mu Sn. So, F ni kadang-kadang boleh jadi F besar, boleh jadi F kecil. Terpulang as long as you can differentiate the friction force dengan applied force. Okay. So, mu S is coefficient of static friction. N is the normal force. When an object at rest, tak ada external force, tak ada objek yang menarik ataupun menolak dia. So, the friction force is equals to 0. Okay, so for this case, an object, kita ada apply force, kita tarik dia. But then, dia masih lagi tidak bergerak. Dia at rest. Meaning that, we have a friction force acting on the object. Okay, yang melawan force kita. If the magnitude of the static friction is greater than the applied force, therefore, the object will not move. If applied force lebih besar daripada static force, dia akan bergerak. And if the magnitude for both Fs dengan F ni dia adalah sama, so objek tu dia berada di antara tengah-tengah lah, dia hampir bergerak. Okay, so ini adalah nilai maksimum for the static friction. Once the applied force exceed this maximum static friction, dia akan bergerak. Okay, so we look at the last diagram over here, an object on a ramp. Okay, so objek ni berada dalam keadaan condong. So, kalau kita letak apa-apa dalam keadaan condong, it will has the tendency to slide down due to the gravity. But in this case, the object is still at rest. So, therefore, we have a static friction against the tendency. Okay, tadi kita dah tengok direction of the vector for weight will always towards the center of the earth. So, yang merah ni akan turun ke bawah. But then, yang menyebabkan dia akan melongsor turun ke bawah is the component of the weight, which is Wx. So, in the case kalau Fs ni greater than Wx, dia akan jadi at rest. But then, if Wx, magnitude of Wx is greater than Fs, so dia akan gerak turun ke bawah lah. Okay, so that is for static friction. Now we look at kinetic friction. Kinetic friction is the friction force that opposes the movement of an object which is moving on rough surface. So, yang tadi tu dia memang tak bergerak. So, static friction. Now, the object is moving on rough surface. So, kita ada kinetic friction. The formula is the same. Cuma kita punya coefficient tu adalah lain lah. Coefficient of kinetic friction. Mu K. Okay, so we can now see the object. When we apply a force, okay, this force is greater than Fk, dia akan bergerak. Walaupun objek ni bergerak, tapi dia masih ada lagi geseran. Okay, so this is what we call as kinetic friction. Okay, so in the case when the object is sliding down, objek tu dia tengah bergerak turun bawah. Okay, so di sini nak kata Wx is greater than the Fk. Okay, so the conclusion is that when the object is at rest, dia ada geseran statik. Okay, dan apabila objek itu bergerak, dia ada geseran kinetik. Okay, let's look at exercise 4.1, basic of forces and free body diagram. But before we start our discussion, I would like you to make correction. Okay, untuk setiap soalan ni, tambah acceleration ke kanan. Okay, tambah acceleration untuk semua soalan. And then, untuk soalan nombor 3, W ni kita tukar kepada T lah. Okay, sebab saya tak nak confusekan dengan weight. Nanti ada orang tanya, Puan bukan ke weight ni turun bawah? So, saya tukar siap-siap T di sini. Right, so for this exercise, you need to write the equation for X and Y components of the following diagrams. Kita kena tulis equation untuk paksi X dan equation untuk paksi Y. Okay, so number 1, here we have 4 vectors. Kita ada 4 vektor. One is applied force. Kemudian kita punya normal force. Normal force kita label sebagai N ataupun R, resultant force. And then Fk adalah kinetic friction. W is the weight. Okay, and then we have acceleration going to the right. Maksudnya objek ini dia bergerak ke kanan. Okay, so these vectors, semua ni yang ikut arah A akan jadi positif. Dan yang kalau untuk paksi Y, ke atas positif, ke bawah negatif. Okay, so let's write the equation for the X component. So along x-axis, we have F equals to 30 minus friction force. Okay, and then F, dia follow direction of the acceleration. So this one is going to be positive, this one is negative. So we're going to write it as F minus Fk. And then I don't want to substitute the value yet sebab kita baru nak tulis equation sahaja. Then along Y component, we have R and W. So common practice, ke atas positif, ke bawah negatif. So R is positive, W is negative. Okay, so R minus W. Itu ada equation according to axis. Then diagram number 2, we have 4 vectors also. But then for the force, dia berada pada untuk force, dia berada di antara paksi X dan Y. So we need to resolve this in order to write the equation for X component and Y component. Okay, so resolve it. We will get Fx here. And then Fy is here. So to write the equation for the X component, kita ada Fx dan juga Fk. In which Fx ni dia follow direction of the motion, direction of acceleration. So dia akan jadi positif, Fk jadi negatif. So X component, kita ada Fx minus dengan Fk. Then along Y axis we have Fy. Then we have W. So the equation for the y component adalah Fy ke atas positif minus W. So in our equation, F yang tengah-tengah ni kita dah tak pakai sebab kita dah resolvekan dia kepada X and Y component. Now we have diagram 3. Diagram 3 dia ada 1, 2, 3, 4 juga komponen. But then vector T, we need to resolve it to X and Y component. Okay, so this one, Tx akan duduk di sini. Okay, and then Ty akan duduk di sini. Okay, to write the equation for the X component. Kita tengok pada pasi X, kita ada F equals to 40. Kemudian kita ada Tx and also Fk. So we have 3 component pada X-axis. So the one yang ikut arah motion ataupun acceleration adalah force equals to 40 degree. So this one is positive, negative Tx, negative Fk. So our equation would become F minus Tx minus Fk. Then along Y, we have R and Ty. W tak ada sebab dia tak bagi dekat free body diagram kita. So for the Y component, R minus Ty. Then diagram number 4, we have 1, 2, 3, 4, 5 vectors. The vectors that need to be resolved adalah F equals to 10 and F equals to 5 Newton. Okay, so F equals to 5, dia akan ada komponen Fy. And also komponen Fx, ni kita buat untuk 5 Newton. Then F equals to 10 pun dia ada komponen Fx 10. Fy pun ada juga Fy 10. So the equation for the X component, okay, along X-axis we have F equals to 30, then we have Fx for the 5 Newton, Fx for the 10 Newton. Okay, then F ini yang ikut arah motion, so dia adalah positif, negative and negative. So our equation for the X component would be F minus Fx for the 5 Newton minus Fx for the 10 Newton. Then vectors along Y, kita ada R, kita ada Fy, kita ada W and kita ada Fy untuk 10. So kita ada 4 term lah yang kita kena include dalam equation Y component. Y component, R positif ke atas, tolak dengan W, tolak dengan Fy 5, tolak dengan Fy 10. Okay, so this is the equation. Okay, so benda yang awak kena ingat daripada sini adalah force yang ikut arah motion akan jadi positif. So let's say the motion is going to the left. Okay, so yang akan jadi positif adalah Fk kita, positif. F kita akan jadi negatif. And then for the y-axis, naik atas positif, turun bawah negatif. Okay, now we move on to the next exercise where you need to draw the FPT and write the equation for X component and Y component. Okay, so di bahagian sini, draw your FPT correctly and then Fx, equation for Fx and equation for Fy. Okay, so kita tengok dulu, for this body over here, we have applied force. Kita ada force yang dikenakan iaitu pull force. And this object is in contact with a surface. So, bila ada objek in contact dengan another object ataupun another surface, we will have normal force going up 90 degree from the surface. Then we can see here, bila ada force, ada pergerakan. Which means kita sepatutnya ada friction force. But then, written here adalah smooth surface. So, bila dia tulis smooth surface, tak ada friction. So, jangan kita label sebagai kinetic friction di sini. So, what else kita ada? So, this object, dia ada mass. So, any object that has mass akan ada weight. So, the weight is going down. Okay, so ini adalah FBT awak. Okay, FBD untuk fizik ni kita boleh lukis pada gambar kita terus macam ni. Or you can transfer it to a dot free body diagram lah. So, kita ada F, kemudian kita ada N, and then we have W with acceleration going to the right. So, for the X component equation equals to F sahaja. Okay, sebab kita tak tolak dengan friction, this object is moving on a smooth surface. Kemudian Fy, N positif minus W. Okay, sebab kalau N ni dah positif, berlawanan arah dengan dia mestilah negatif. Now we move on to number 2. Okay, number 2 we have a force over here. Okay, so in this case kita punya axis X dengan Y. So according to this vector over here, sebabkan dia ada angle, we need to resolve it. This one is Fx and here is Fy. Then kita ada friction, kinetic friction. So which means this is not a smooth surface. Dia tak tulis pun, dia tak bagi tahu. Dan dia bagi Fk. So maksudnya ada geseran. And then this object has a mass, jadi dia ada weight going down. And then also this object is in contact with the surface, jadi dia akan ada normal force dengan surface N. Okay, so for your FBD, kita kena transfer semua force yang kita dah labelkan. And don't forget the vector that we have resolved. So to write the equation for the x-axis, kita tengok pada pasti x kita ada komponen apa. Kita ada Fx dengan Fk. So therefore equals to Fx minus Fk. Along y kita ada N, Fy dan juga W. So going up positif, so N dan Fy pun naik atas juga. So dia kena tambah, tolak dengan W berlainan arah. Okay, and then remember Fx ni dia positif sebab dia ikut arah motion. Now for number 3, kita ada force ditarik ke atas and then we have Fk. So this object has a mass, jadi kita akan ada weight daripada titik tengah akan terus turun straight W. And then this object is in contact with the surface 90 degree from the surface, naik atas 90 degree, itu adalah normal force ataupun resultant force. Okay, so for this case, kita punya paksi X dan Y kita ambil secara sengit lah, which is this Y, this is X. Okay, now kita pindahkan semua force. This is the origin. Force going to the right. Kita ada normal naik ke atas. And then we have W. W masih lagi towards the center of the earth. And then kita ada Fk. Okay, sekarang angle 30 ni duduk di mana? Okay, so we know untuk triangle, dia punya total angle adalah 180. Okay, di mana di sini adalah right angle triangle. So, sini dia dah ambil 90 degree. 180 tolak 90, kita tinggal 90 kan? Okay, so 90 kita ada 30 kat sini. 90 tolak dengan 30, kita ada 60 degree which is here. So, this is 60 degree. And the angle over here adalah right angle triangle. Okay, so 90 tolak 60 ini adalah 30 degree. So which means 30 degree ni dia berada di sini. So this is our FBD. Okay, so according to this FBD, kita kena resolve W. So this one would be WY. And this one is WX. Okay, so untuk dapatkan nilai WY, dia akan jadi W cos 30 sebab angle berada dekat dengan paksi Y. For WX, WX adalah W sin 30. Okay, sebab tu kita buat paksi kita sengit supaya kita kena resolve satu sahaja vektor. Okay, kalau kita buat kita punya axis straight macam biasa, kita ada 1, 2, 3 vektor nak kena resolve. Instead of this one, kita perlu resolve W sahaja. Okay, so along x-axis, F, FK, and WX. Along Y and WY. And then arah motion dia ke atas. So along x-axis yang ikut arah E adalah positif. So that is positive, negative, negative equals to F minus FK minus WX. For y-axis, and positive tolak dengan WY. Okay, so that's how you can draw the FPD. Lepas tu buat equation for X and Y component. Okay, so for number 2 tadi, sebabkan kita ada Fx ni kan. So nanti bila kita dalam calculation, Fx tu kita kembangkan lah. Jadi F cos 30 minus Fk for this one. And plus Fy adalah F sin 30 minus W. For number 3, F minus Fk minus Wx adalah W sin 30 equals for the Y component N minus W cos 30. Okay, so the rest number 4 until number 8, they are your homework. Okay, kena siapkan homework 4 sampai 8.